Okay, so good day. We will discuss all about acoustics, and in order to do that, we will use the PowerPoint presentation by Paul E. Pippin, a professor of physics from the Southern Polytechnic State University. So, after this presentation, you should be able to compute intensity and intensity levels of sound and correlate with the distance to a source. Apply the Doppler effect to predict apparent changes in frequency due to relative velocities of a source and a listener. Acoustics is the branch of science that deals with the physiological aspects of sound. For example, in a theater or room, an engineer is concerned with how clearly sounds can be heard or transmitted. Audible sound waves. Sometimes it is useful to narrow the classification of sound to those that are audible, those that can be heard. The following definitions are used. Audible sound has the frequencies from 20 to 20,000 Hz, and infrasonic are frequencies below the audible range, and ultrasonic frequencies above the audible range. Comparison of sensory effects with physical measurements. So you have three sensory effects: loudness, pitch, and quality. There's physical property of intensity, frequency, and waveform consecutively. Physical properties are measurable and repeatable. Sound intensity is the power transferred by a sound wave per unit area normal to the direction of wave propagation, giving us the formula I is equals to P over A, that is the units of watts per meter squared. Isotropic source of sound. An isotropic source propagates sound in ever-increasing spherical waves as shown. The intensity I is given by P over A, or P is equals to 4 pi r squared, meaning intensity I decreases with the square of the distance r from the isotropic sound source. Comparison of sound intensities. The inverse square relationship means a sound that is twice as far is 1/4 as intense, and one that is 3 times as far away is 1/9 as intense, giving us I1 R1 squared is equals to I2 R2 squared. A horn blows with constant power. A child 8 meters away hears a sound of intensity 0.6 watts per meter squared. What is the intensity heard by his mother 20 meters away? What is the power of the source? So given I1 is equals to 0.60 watts per meter squared, R1 8 meters, and R2 20 meters. So if you will derive it, we will get 0.096 watts per meter squared. Then what is the power? Since power is equals to 4 pi R1 squared times I1, we will have P is equals to 7.54 watts. The same result is found from P is equals to 4 pi R2 squared and I squared. Range of intensity. The hearing threshold is the standard minimum of intensity for audible sound. Its value I0 is 1 by 10 raised to negative 12 watts per meter squared. The pain threshold is the maximum intensity IP that the average ear can record without feeling of or pain. Pain threshold IP is equals to 1 watt per meter squared. Due to the wide range of sound intensities from 1 by 10 raised to negative 12 watt per meter squared to 1 watt per meter squared, a logarithmic scale is defined as the intensity level in decibels. Intensity level B is equals to 10 log I over I0 in decibels, where B is the intensity level of a sound whose intensity is I and I0 is equals to 1 by 10 raised to negative 12 watt per meter squared. Example number 2, find the intensity level of a sound whose intensity is 1 by 10 raised to negative 7 watt per meter squared. If we will substitute it to the formula in the previous slide, then we will get intensity level B is equals to 50 decibels. Intensity levels of common sounds: sibs or whisper, 20 decibels. Normal conversation, 65 decibels. Subway, 100 decibels. And 100 to 160 decibels for jet engines. Hearing threshold 0 decibels, and pain threshold 120 decibels. Comparison of two sounds. Often two sounds are compared by intensity levels, but remember intensity levels are logarithmic. A sound that is 100 times as intense as another is only 20 decibels larger. Difference in intensity levels. Consider two sounds of intensity levels B1 and B2. We will equate it to each other. If we will have their difference, then we will have the formula B2 minus B1 equals 10 log I2 over I1. How much more intense is a 60 decibel sound than a 30 decibel sound? B2, since we have the formula B2 minus B1 equals 10 log I2 over I1, then we will have I2 is equals to 1000 I1. Interference and beat. Remember that beat frequency is equals to F apostrophe minus F. The Doppler effect states refers to the apparent change in frequency of the sound when there is relative motion of the source and listener. So F is equals to V over wavelength. Left person hears lower F due to longer wavelength. Right person hears a higher F due to shorter wavelength. Apparent FO is affected by motion. General formula for Doppler effect. FO is equals to Fs quantity V plus VO over V minus Vs quantity, where FO is the observed frequency, Fs is the frequency of source, big V is velocity of sound, small VO velocity of observer, and small Vs velocity of source. Speeds are reckoned as positive for approach and negative for recession. A boy on a bicycle moves north at 10 meters per second. Following the boy is a truck traveling north at 30 meters per second. The truck's horn blows at a frequency of 500 Hz. What is the apparent frequency heard by the boy? Assume sound travels at 340 meters per second. The truck is approaching, the boy is fleeing. Thus, Vs is positive and Vo is negative. When applying the Doppler equation, we will get FO is equals to 532 Hz. Summary of acoustics, so that would be just the summary. And the summary of formulas, and that would be all. Thank you.